Hello students, welcome to the another session. In today's session, we will be discussing about the straight lines. And this session is completely conceptual review. What are the things we are going to learn in today's class? Different forms of straight lines, distance of a line from a point, position of a point with respect to the line, angle between lines, image, foot of the perpendicular, and angular bisector. So let us get into the chapter straight away. First of all, to talk about the line, we need to know few things. That is inclination of the line or slope of the line. Okay. So where if I want to talk about a straight line, I need to know the inclination and slope, other things. So a line makes an angle theta with positive x-axis measured in the positive direction or positive x-axis is theta means if this is the positive x-axis, positive direction is this. So a line is there which is making an angle of theta, then slope of this line denoted by m, generally slope denoted by m, that is equal to tan theta. So this theta can be measured in here 0 to pi. 0 is including, pi is excluding. So, for example, if I am assuming this one as the y-axis, 0 less than theta less than pi by 2, the slope m is greater than 0. Pi by 2 less than theta less than pi, m will be negative. And if theta is equal to pi by 2, the slope is undefined. Means at that time the line is perpendicular to x-axis. So m is equal to 0, line is parallel to x-axis, and m is equal to undefined. Okay, m is equal to undefined from infinite, then it will be perpendicular to x-axis. Okay, and now with the help of this one, we need to derive the slope of line joining 2 points x1, y1 and x2, y2. So if you take this one as the coordinate system, so here a x1, y1 is here, and here this is bx2, y2. bx2, y2. What is the slope of joining this? So in that case, you complete this triangle. So this is the positive x-axis, this parallel to this one. So if this angle is theta, this angle is also theta. So here this y value is y2, here y value is y1. So this value is y2 minus y1. Here x value is x1, here this is x2 and this is x1. This length will be equal to x2 minus x1. As per the right angle triangle and tan, so tan theta is equals to y2 minus y1 by x2 minus x1. And clearly we are mentioning x1 is not equal to x2. If x1 is equal to x2, you will be getting the line like this, vertical line, where tan theta is not defined. So that is our special case, line parallel to y-axis. So what is the slope of line joining 2 points? y2 minus y1 by x2 minus x1. Right? So exactly what we learned in this one, it is simply what is the inclination of a line and how to find the slope of line joining 2 points x1, y1 and x2, y2. Now, if two lines two non-vertical lines are parallel if their slopes are equal. Why non-vertical specially mentioned here and here? Because vertical lines, okay, so for vertical lines, slope is undefined. For vertical line, slope is undefined. So that's why we are saying two non-vertical lines are said to be parallel. These two are parallel. So if slope is m, automatically slope of this line is also equals to m. Next, two non-vertical lines are perpendicular. Non-vertical lines means one line is like this and one line is what this one. How it is perpendicular? Perpendicular means this angle is 90 degrees. So if the slope is m1, its slope is m2. Here m1, m2 is equal to minus 1. Product of the slopes is minus 1. Why we are mentioning non-vertical? For example, x-axis is horizontal, y-axis vertical. This slope is equal to 0. Its slope is undefined. So, though these two are mutually perpendicular, the product of the slopes is not equal to 1. So, it's a special case when the vertical line and horizontal line, though they are mutually perpendicular, this particular condition cannot be considered. Next part is if theta is the acute angle between two non-vertical lines whose slopes are m1, m2, tan theta is equal to acute angle. I'm talking about acute angle. So theta is acute, tan theta should be positive. So that's why we have taken modulus. So what is that exactly? So if you look at this is the x-axis. This is one line with the slope m1 and this is another line slope m2. What is this angle? So this is the with the slope m1. This is the slope m2. For example, this angle is beta. This angle is alpha. Okay. So theta is equal to beta minus alpha. Tan theta is equal to tan of beta minus alpha. So what will happen? Tan theta is equal to tan beta m2 minus m1 by 1 plus m1 m2. Why theta I'm talking about? Because angle between two lines, okay, so you can take this angle or you can take this angle. So if this is theta, this angle is pi minus theta. One among this one is acute, one among them is another one is the obtuse. So I'm not sure whether this is acute or this one is acute. So what we basically will talk, if theta is acute, we'll keep the modulus. We'll keep the modulus for total value what you are finding. So important points here. Two parallel lines slopes. If slopes are equal, they are said to be parallel. Two lines are perpendicular, then product of the slopes is equal to minus 1, except the lines are parallel to x and y axis. And if two lines slopes are m1 and m2, the acute angle between them is theta, then tan theta is equal to modulus of m1 minus m2 by 1 plus m1 m2. Okay. Now, what are the different types of straight lines we have? The general form of the line is ax plus by plus c is equal to 0. So, the linear relation between the lines, the linear relation between x and y axis, okay, linear relation between x and y, that is ax plus by plus c is equal to 0. So we call it as the, okay, linear relation is the straight line. That is the general form of the straight line. Slope intercept form. In the slope intercept form, m is the slope of the line and c is the y-intercept. Point slope form, where slope of the line is m and passing through x1, y1. 2 point form where two line equation of the line passing through x1, y1, x2, y2. If the line is passing through x1, y1 and x2, y2, okay, this is x1, y1 and this is x2, y2. Then x-intercept is A, y-intercept is B. Intercept form, that is x by A plus y by B is equal to 1. Normal form is x cos alpha plus y sin alpha is equal to P. And here important thing is P has to be positive. Okay. And symmetric form and parametric form. Both are one comes from the other. X minus x1 by cos theta is equal to y minus y1 by sin theta. And if I want to find a line point on this particular line, which is r units away from x1, y1, I'll go for the parametric form. So for each and every form of the straight line, there is a clear significance. And for example, if you take this normal form, what is that? If these are the coordinate axes and this is the line which is P units away from the origin and this angle is alpha, this equation is x cos alpha plus y sin alpha is equal to P. This is the significance of this particular line. Okay. So just have a look at all the forms of the lines. Okay. Just have a look at all the forms of lines. The perpendicular distance from point C. First, let us take this one. If the line is AX plus BY is equal to C, then you divide with a by root over a square plus b square into x. B by root over a square plus b square is equal to c by root over a square plus b square. Now take this one as cos alpha and take this one as sin alpha. So it is x cos alpha plus y sin alpha is equal to P based on the normal form. So this P is the perpendicular distance. That is mod C by root over A square plus B square. Similarly, if you shift the origin to x1, y1, the line AX plus BY is equal to C. Convert into AX plus BY is equal to AX1 plus. So from there you will be getting this one. The perpendicular distance from x1, y1 and the perpendicular distance from 0, comma 0 to a particular line. So these two are very crucial formulas and particularly in the competitive exam. Next one is the distance between two parallel lines. What is that? This is a line and this is another line. Both are parallel. This is AX plus BY plus C1 is equal to 0. AX plus BY plus C2 is equal to 0. So the slopes are equal. So they are said to be parallel. So what will be the distance between these two? So the distance D is equal to modulus of C1 minus C2 by root over A square plus B square. Now if I want to find a line, parallel to these two and midway through this. So simply you can write it as AX plus BY plus C1 plus C2 by 2 is equal to 0. Okay. This is the line equidistant from these two, equidistant from these two lines. So here I'm talking about a line which dividing line segment join these two in the ratio. For example, this is the line AX plus BY plus C is equal to 0. Here X1, Y1 we have, somewhere here X2, Y2 we have. In which ratio this line segment dividing these two? In the ratio of M is to N. So what is M and M value? Simply you drop the perpendicular here, you drop the perpendicular. This is P1, this is P2. So these are the two similar triangles. So from here M by N is equal to P1 by P2 is equal. Perpendicular distance from x1, y1 to this one is modulus of ax1 plus by1 plus c by modulus of ax2 plus by2 plus c. But actually, before getting into this one, the next one is important. What is that point? So what this line AX plus BY plus C is doing. This is AX plus BY plus C is equal to 0. So for this one, for example, if this is the positive direction, this will be the negative direction. Or if this is the negative direction, then it will be positive direction. The line is dividing the plane into two equal parts. So similarly, what happens for this line, if these 2 points lying either side, so this one of them should be negative. So that's why we'll go minus of ax1 plus by1 plus c by ax2 plus by2 plus c. So if this is M by N, if this is positive, this line is dividing these two internally. If this ratio is negative, this line is dividing externally. Okay? And similarly, if this is the line L is equal to 0, if this is x1, y1, substitute x1, y1 in this L is equal to 0, we call it as L11. Substitute x2, y2, and that is L22. If L11 into L22 greater than 0, both the points lying same side, and L11 and L22 less than 0, the points are lying either side. Okay? So L11 positive and L22 positive, both are lying same side. So if this is L is equal to 0, x1, y1 here, x2, y2 here, x1, y1 and x2, y2. In this situation, L11 into L22 greater than 0. So whether this is the positive side or negative side doesn't matter, but both are negative, both are positive, it's okay. If this is the line L is equal to 0, x1, y1 here and x2, y2 here, in this case, L11, L22 is negative. And the last point here, L is equal to 0. L dash is equal to 0. Two parallel lines. L is equal to 0. L dash is equal to 0. If x1, y1 is here. So for example, for this one, it is the positive side. Then for this one, it is going to be the negative side. If this is for this one negative side, for this one it will be positive side. So that's why L11 into L dash 11 negative for the point lying between two parallel lines. Two parallel lines. Okay. So here in this page, the most important point is the line dividing x1, y1 and x2, y2 in the ratio of which ratio minus of L11 is to L22. That is A minus of AX1 plus BY1 plus C by AX2 plus BY2 plus C. Here one extra Y has come. This is you need to take it. Okay? Right. Here three key points are there. First key point is if the transversal cuts the sides of a triangle ABC. Let me take the triangle as like this ABC and a transversal means a line which is cutting these three. BC at D, CA at E and AB at F. Then BD by CD or BD by DC into CE by EA into AF by FB is equal to -1. Okay, very important property this. Okay, may not come directly in some of the questions, but the conceptually you can apply in most of the cases. Okay, and if two lines are non-parallel, then they are intersecting. So if this is one line and this is another line, this is called the common point or point of intersection. So how we will be writing this one? It is simply a1x plus b1y plus c1 is equal to 0. A2x plus B2y plus C2 is equal to 0. Basically, you make multiply this one with A2, this one with A1, subtract, you will get Y value. Similarly, multiply this one with B2, this one with B1, subtract, Y will be eliminated, X value will come. Or if you apply the matrices Kramer's rule method, that is X, Y, 1, you need to write. Leave the X coefficient, start with Y coefficient B1, B2, C1, C2. Now A1, A2, B1, B2. X by B1, C2 minus B2, C1 is equal to Y by C1, A2 minus C2, A1 is equal to 1 by A1, B2 minus A2, B1. So from there you'll get X and Y value. And if more than two lines are passing through common point, this point is called concurrent point. What you call? Concurrent point. Okay. So here, what is this condition when a line is meeting the sides of triangle BC, CE, AB, and DEF respectively? BD by DC into CE by EA into AF by FB is equal -1. And two non-parallel lines always intersect and their point of intersection is, this is how you need to calculate or you can remember this one. B1 C2 minus B2 C1 by A1 B2 minus A2 B1 and C1 A2 minus C2 A1 by A1 B2 minus A2 B1. And here only they are talking about the last point. Three or more lines are passing through one common point. This is called concurrent point, and these three lines are called concurrent lines. For example, this is L1, this is L2, this is L3, and L3 can be written as L1 plus lambda L2. So for different values of lambda, you'll get different lines. But here typically, for example, A1x plus B1y plus C1 is equal to 0. A2x plus B2y plus C2 is equal to 0. Next one is A3x plus B3y plus C3 is equal to 0. If these three lines are said to be concurrent, these three lines are said to be concurrent, then the condition is det of A1 B1 C1, A2 B2 C2, A3 B3 C3 is equal to 0. In most of the competitive exams, three lines will be given with one unknown. They'll say they are concurrent. What is the unknown value? So the best thing is you take two lines, find the point of intersection, substitute in the third one, or you can go for this one. Or you can also like this A1 into B1 C2 minus B2 C1 plus A2 into okay B2 C3 minus B3 C2 plus A3 into okay B3 C1 minus B1 C3 is equal to 0. Okay. At instead of taking this one, point of intersection of first two lines is this one. You substitute in the third equation. You are going to get that one. Or it will be like A1 into B2 C3 minus B3 C2 plus B1 into C2 A3 minus C3 A2 plus C1 into okay A2 B3 minus A3 B2 is equal to 0. But the best thing what I suggest here is going for this condition. That's more than sufficient. So if this is L1 is equal to 0 and L2 is equal to 0, L1 is equal to 0, L2 is equal to 0, then any line through the intersection of this one is L1 plus lambda L2 is equal. So the concurrent line of L1 is equal 0 and L2 is equal 0, you can write L1 plus lambda L2 is equal to 0. This is another important point, that is L1 plus lambda L2 is equal to 0 represents a line through the point of intersection of L1 is equal to 0 and L2 is equal to 0. Okay, right. In the initial beginning, we have talked about two lines are said to be M whose slopes are M1, M2. What is the angle between them? So here if the line is A1x plus B1y plus C1 is equal to 0, A2x plus B2y plus C2 is equal to 0, the angle between them cos theta is equal to A1 A2 plus B1 B2 by root over A1 square plus B1 square into root over A2 square plus B2 square. And another angle is pi minus theta. One angle is theta, another one is pi minus theta. So from here only we can say that like A1 A2 plus B1 B2 is equal to 0, then theta is equal to 90 degrees. The lines are parallel. And if this value is equal to 1, that means on doing this one, A1 by A2 is equal to B1 by B2. That means theta is equal to 0. The lines are said to be parallel. So this is the cos theta value. This is cos theta. So from here you can go ahead with sin theta. Sin theta is equal to A1 B2 minus A2 B1 by root over A1 square plus B1 square into root over A2 square plus B2 square. Okay. So you can take this sin theta value also. Now if I want to write in terms of tan theta, okay, M is the slope of a line which equally inclined to two intersecting lines. So here this is the line with the slope M1, this is the line with slope M2, and uh, you have a line Equally inclined. Equally inclined means same angle. This angle is equal this angle. With this slope is up. So this is theta, this is theta. Angle is always measured in the anti-clockwise direction. Tan theta is equal to m1 minus m by 1 plus m1. Okay, this slope is m. And here m minus m of 2 by 1 plus m2. So this is a value. Why I am keeping plus or minus? I don't know whether this is m1 or this is m2. It can be reversed. When it is reversed, automatically minus sign will be taken up. And this is another one. If the slope of a line which makes an angle alpha with the line having the slope m means here this point, what is this point means? If this is the line with the slope m, I want to find the slope of this line which is making an angle alpha. Or I need to find a line which is this is also making alpha. Okay. So if I say this is m1, m1 minus m by 1 plus m1 m is equal to tan alpha. So that's why this value I will take m minus tan alpha by 1 plus m tan alpha. Another one is m plus tan alpha by 1 minus m tan alpha. Simple. The previous case, what is tan alpha is equal to m1 minus m by 1 plus mm1. So from here, what is m1 you can write. And similarly, tan theta is equal to, this is m2, m minus m2 by 1 plus mm2. So one is giving this one and another one is giving this one. And equation of the line passing through x1, y1, making an angle alpha with the line y is equal to mx plus c. Directly y minus y1 is equal to tan of theta plus or minus alpha into x minus x1. Because this sign is given, one with this one or this. So this is with the problem depending on the situation you can remember. But this one and knowing this one and knowing this one are very, very important. Two lines are parallel. If A1 by A2 is equal to B1 by B2, coincident, okay, parallel, coincident, perpendicular. What is the difference between parallel and coincident? Like if I write x plus y plus 1 is equal to 0, x plus y plus 2 is equal to 0. So these are parallel. For example, x plus y plus 1 is equal to 0, 2x plus 2y plus 2 is equal to 0. These two lines are coincident lines. And A1, A2 plus B1, B2 is equal to 0. The lines are said to be perpendicular. The lines are said to be perpendicular. So before going to this one, let me discuss one point here. This is the line AX plus BY plus C is equal to 0. I need to find a line parallel to this one passing through x1, y1. So slope of this line is minus a by b. Uh, any line parallel to this one passing through x1, y1 will be a into x minus x1 plus b into y minus y1 is equal to 0. And I need to find a perpendicular line passing through x1, y1 perpendicular to this. This equation will be b times of x minus x1 minus a times of y minus y1 is equal to 0. A into x minus x1 plus b into y minus y1 is equal to 0 is a parallel. B into x minus x1 minus a into y minus y1 is equal to 0 is perpendicular. Now, in this particular slide, we are talking about foot of the perpendicular and image. Okay. So, if this is the line ax plus by plus c is equal to 0, This is the point x1, y1. If you draw a perpendicular and where it is meeting, this is called foot of the perpendicular. So if this is h comma k, so what happened? This slope will be perpendicular to this slope. This slope is equal to minus a by b, and for this slope is k minus y1 by h minus x1. So product of the slopes k minus y1 by h minus x1 into minus a by b is equal minus 1. From here you are going to get h minus x1 by a is equal k minus y1 by b is equal to minus of ax1 plus by1 plus c. This is by ratio and proportionality we will be getting. Now, what is the image? If this is the line, this is the point x1, y1. So, if you drop the thing, this is the foot of the perpendicular. Same distance you go here. This is called image. So, if image of A with respect to the line L is equal 0 is B, midpoint of AB is this point. So AB is perpendicular to L is equal 0. Midpoint of AB lies on the line L is equal to 0. So you are going to get the equation this one. Okay. This is the foot of the perpendicular case and this is the, what is the image. Okay. So here we can talk about certain cases, etc. So if you take the coordinate axis, if this point is x comma y, image of x comma y with respect to x axis is x comma minus y. Image of x comma y with respect to y axis will be equal to minus x comma y. Image of x comma y with respect to the r is in with respect to, so it will be midpoint. So it will be minus x comma minus y. And image of this one also this, image of this one also. Okay. Anyone, if someone is asking image of p x comma y with respect to line x is equal to y, just simply interchange x and y. Interchange x and y. In this slide, we are talking about parallelogram is given, right? So this is a1x plus b1y plus c1 is equal to 0. This is a1x plus b1y plus c2 is equal to 0. So if you extend here, you are going to get the distance between these two as p1. And you have, this is the line equation a2x plus b2y plus d1 is equal to 0 and this line is a2x plus b2y plus d2 is equal to 0 and this distance is p2 and angle between these two is r theta. Then area of this triangle is P1 P2 by sine theta. Why P1 P2 by sine theta? Whenever you drop like this distance is P2. So this into base into height. So base is P1, height is this one, P1 by sine theta. So area of the parallelogram is P1 P2 by sine theta. If you take P1, that is C1 minus C2 by root over A1 square plus B1 square. P2 is equal D1 minus D2 by root over A2 square plus B2 square. And if theta is the angle between this one, I wanted I'll go with sine theta. That is A1 B2 minus A2 B1 by root over A1 square plus B1 square into from root over A2 square plus B2 square. From there you are going to get. Only thing here you need to take the modulus because area cannot be negative. And simpler form P1 P2 by sine theta. Next one is angular bisector. What is that angular bisector? This is the line A1x plus B1y plus C1 is equal to 0. This is the line A2x plus B2y plus C2 is equal to 0. Then non-parallel lines. Angular bisector, angular bisector means if this is the point Px1, y1, set of points equidistant from given two lines is called. So this is for example P1, this is P1, this is P2. So P1 should be equal to P2. So perpendicular distance from x1, y1 to this line is a modulus of a1x plus x1 plus b1, y1 plus c1 by root over a1 square plus b1 square. This is P1 and similarly P2 is equal modulus of a2x2 plus b2y2 plus C2 by root over A2 square plus B2 square. So P1, P2, locus of X1, Y1 such that P1, P2, P1 is equal P2. So you are going to get this angular bisector. Okay. So with this one, I'm concluding this basics of the straight line. But please understand, you learn lot many formulas, lot many shortcuts with the questions which we are going to discuss. Okay. Thank you very much. See you later. Bye.